We're going to look at one of the biggest BS stories in our lifetime. If you still want to believe we went to the moon just from this one single example I'm going to give you, then you deserve to check yourself into some kind of hospital and learn how to get rid of your cognitive dissonance. So today what we're going to look at is we are going to look at simple power transmission of TV signals, the way they were done back in the 1960s, the way NASA itself admits they were done, and we're going to see how impossible it is for them to set up any kind of antenna on the moon and have it transmit to the Earth using the power they had back then. Then we're going to come back to this, and I'm going to have links to all this stuff in the comment section below. So to make this as soon as possible, let's jump to the next section. Now, since the public loves to use Wikipedia because it's God on earth truth, we're going to use it. Now, you can find other external sources for this. I found it at space.com and a few other places. Again, the links will be at the bottom here. Let's look at analog television, because that is how the television signals were transmitted supposedly from the Apollo missions. And we're going to particularly look at power. Now, one thing we have to look at here is there was a supposed accident on Apollo 13. So they upgraded, supposedly, the batteries on every other one after that. But we're going to look then at, let's look at Apollo 13 and before, because we had Apollo 11 and 12 where they did plenty of transmissions from the moon. And I'm not even going to get into the part that the Earth was spinning, the moon was spinning, they're moving in conjunction from one another. I don't know if I'll get it covered here, but there's one area where it says it wasn't a problem for these cameras because even when they were filming the lunar module descending or moving in space, they were, and the astronauts on the surface, they were moving slow enough so it wouldn't blur the picture and things like that, because they get into how they had to shrink it down to a very narrow signal, and that's just technical BS to try to get around the fact that there wasn't enough power to transmit what they had on the moon, even 50 feet away probably. But people want to believe it went from the Earth to the moon. We talked to them. Think about this. We had transmission of audio back and forth from Houston to the astronauts. The astronauts could talk to each other. They could both hear each other. These are transmitters, receivers, microphones. These are all using power. These astronauts standing on the surface of the moon, supposedly their whole backpack, or almost all of it, had to be used for oxygen. So where were the batteries they were using? And these are things that I'm throwing out there for you guys to be able to even add more to what I'm going to add here. So now the LM, that's the lunar module. That's what we're concerned with, because when the lunar module was on the moon, it's not connected to the service module, which was supposedly rotating around waiting for them to come back. And it tells you what the electrical system was designed for. Guess what? None of it ever mentions powering the antenna itself. Can you believe that? They had a whole 65 kilowatts per hour at 4 kilowatts max for a 35-hour lunar stay. So check this out. They couldn't use more than 4 kilowatts. That's 4,000 watts of power. Or they run out of power before they left. And you know they don't even want to get close to running out of power before they left, would you? And here's the killer. You ready for this? 28 volts DC. 28 volts DC went into inverters to convert it to AC. And I can tell you, even 10 years ago, these inverters that we used to be able to get were a lot less efficient than what they are now. God only knows how bad it was in the late 1960s. But we're going to say they're extremely efficient, even more efficient than today. In fact, we're not going to consider any power loss going through an inverter. How's that? And I'm not going to use any power loss going through wires. And I'm not going to consider any power loss transmitting from the air or through no air. I don't know what it's transmitting through. I guess it's just unimpeded. But from the surface back to the lunar module, through the antenna, and then back to the Earth, and then from the Earth back up. We're not going to even account for that. Originally, and this is what we're looking at, it was designed for 3 fuel cells. And they added one after the Apollo 13 so they could have more power. Well, when you look at the diagram, you show me where they had room to fit it in. And the lunar modules were made in advance, so they didn't recast them again. Here's what we're looking at. Here's the most important thing right here, the lunar module descent. There's 3 different batteries they could use. The CSM, that is the actual device that supposedly orbited the moon as they descended in the lunar module. The service module is what this is mostly known as. So we can't even count any of this because this wasn't connected to the lunar module. Now, there's 2 different battery types, lunar module descent, lunar module ascent. We're only interested in lunar module descent. As they say in this PDF, link below, these are the only batteries used the entire time the astronauts were on the surface of the moon. 29 stinking volts. It's a little bit more than 2 car batteries, guys. 400 amp hours capacity. They couldn't use much, and plus they're in what, 251 degrees Celsius I think it is during the day, and minus whatever if it's in the shade. Very efficient. We're only interested in the, like I said, the details are in this thing. I'm not lying to you. Look it up. They're only using the lunar module batteries when they're on the surface, period. Now here's the design where they put the batteries in. And of course they're showing them very sleek and thin and everything, like they could just slide them into the wall or something. I'd like to see a 29 volt battery, even today, with 400 amp hours each, be a nice little thin thing you can just slide into the wall. How come the technology hasn't reached us yet? You know how big a car battery is? That's 12 volts. Nowhere near this kind of amperage. Anyway, let's keep going. Now, if you know how to read a schematic, you will see that the lunar batteries are right here. Now, the most they could use for the antenna on the surface of the moon, which they don't show, is the largest circuit breaker that they have. Like if you have, let's say in your house, you have an air conditioner unit that requires 200 amps, let's say. You can't connect it to a 100 amp service. It'll blow the circuit right away, or it'll melt the wires if it doesn't blow the circuit. That's why we have circuit breakers. Most washers and dryers in the United States either run on 30 amp or 50 amp type of things, and you can't overload them. You can only go as much as the highest amp you have. Now, what's the highest here? Total is 100 amps. Now, as they keep going out, you'll see that each bus that goes out to these different subsystems, they only get 30 amps each. So 30 amps is all that was available on the surface. These 100 amps, if you know how to read a schematic, these are all internal. They don't get to the outside, but we're going to say they do. We're going to say 100 amps goes out to the antenna. All the power, 100% of the power we're going to use for the antenna when they're out there, okay? Here we go. Lunar battery was a spare added after Apollo 13, so we don't care about that. We're going to use Apollo 11, the most famous one, the first time on the moon, as the example. All right, so the most important thing to remember is they had 100 amps available in the circuit, and here we go. 400 amp hours capacity. Nothing, as you're going to see. So let's look at something else here. Now let's take a look at something that everybody can relate to. We're going to look at WABC News, or WABC transmissions. We're going to look at WABC out of New York City, which has its antenna on top of the Empire State Building, so there's absolutely nothing in the way, no terrain, no other buildings. It's the highest building there, other than the World Trade Center buildings, and the antenna faces southwest, so that's not even facing towards it. So let's look at WABC, and we're going to look at analog, because analog is what they used in the 60s and 70s, and I already know what somebody's going to say. Yeah, they had technology ahead of ours. They went digital. Well, stuff your ignorance where it doesn't show, and then pull it out again, wipe your face off, and learn that digital requires much more power than analog. So I'm giving NASA every benefit of the doubt here. So we have ABC out of New York. It's AB7. That's the channel in New York. And anybody who grew up in the United States in the 60s and 70s knew that, generally speaking, the higher the channel, the highest you would get on regular channels was 13, and then you would get into the VHF band, or I'm sorry, you would drop into the UHF band to get other channels. But generally speaking, this was just broadcast on the VHF band. And what we have here is, I want to focus in on the power that this uses. Here we go. The transmitter uses 34 kilowatts of power. That's 3,000, well, that's 34 times 1,000, 34,000 watts of power. Now, how far can this be seen when you had analog television? How far could you see it? Maybe 40, 50 miles. At 50 miles, you were definitely getting a lot of snow and a lot of mess up. Maybe if atmospheric conditions were perfect, maybe 60 miles, but it would still be a very snowy picture. And I'm giving benefit of the doubt, saying it was a Channel 13, best technology back then, with the strongest power, which, by the way, wasn't 34 kilowatts. It wasn't allowed to have that much back then. But now it is 34 kilowatts of power. Will transmit 50 miles. 34 kilowatts transmits 50 miles. Now, there's one more place I want to look here. This is another Wikipedia article called List of North American Broadcast Station Classes, link below. Low power in the U.S. Low power TV, U.S. VHF, these are the channels I was just talking about, 2 to 13. These are the most efficient. There's no more efficient transmission of television than this, guys. There just isn't. Everything else uses more power. Everything else. This is why VHF was picked for the main channels in the United States. It's because it was the most efficient. There's nothing more efficient to transmit television signals. 3 kilowatts. Analog video. That's what we're talking about. 3 kilowatts. And how far does it go? At most 50 miles. And then you get into all kind of fuzzy stuff. Now, people don't know that today because everything's digital, and you got these antennas that bring in the digital signal. But if you happen to live somewhere where they have an analog signal, this is the lowest figure I can figure, 3 kilowatts. This is roughly equivalent to what they used on the moon. If they used every stinking ounce of power on the moon, then they beat it by 1 kilowatt. So, how can TV channels on Earth using the same power or more, the 34 kilowatt is the one that goes 60 miles. In any case, we're going to use this. Everything in advantage, to the advantage of NASA. 3 kilowatts goes 50 miles, and 3 kilowatts on the moon goes how far? Well, it's actually 4. So let's give it 1/4 more. Actually, let's give it double. Let's give it double. 6 kilowatts. So it goes 100 miles. And if they used 100% of the power, they're not keeping air conditioning or heating going on in the lunar module. The computer's not working. The oxygen inside isn't going. It's not keeping the inside pressurized, and all that kind of stuff. Light systems. Again, no loss of power because of going through inverters and different wires and different things like that, which cracks me up. There's a picture, if I find it, I'll put it in here, which showing the camera outside in supposedly 251 degrees Celsius temperature in the sun, and it's got the regular plastic coating on the wires going to it. It's just absolutely insane that we believe this stuff. Anyway, so doubling the power gives 100 miles, way more than what they could possibly use on the lunar module. And what are we told? We are told that only 4 kilowatts, if they use the entire max, risking being able to take off, They were able to transmit 232,000 miles. Not only that, but the moon was moving, the earth was moving the entire time. All they did was go out and stick the antenna out and point it straight up in the sky. There was no rotation of the antenna, nothing like that. And look at this too. You see the antenna up here pointing straight up? So the whole time the lunar module, it's pitching and going back and forth and different things like that. It's actually going sideways and it's rotating every which way, but it never lost the signal with the earth. Come on! Are you serious? No, you're freaking insane if you think that 4 kilowatts could transmit 232,000 miles with an antenna that was never pointed straight at Houston, and if it was only for the slightest moment. It never rotated. The astronauts left it there the entire stay. Absolutely insane stuff. We didn't go to the moon, guys. Wake up. Okay, guys, let's drive the point home with 4 different pictures. You know, it's okay to be fooled once. We were naive at one time. We were brainwashed, actually, into believing our government no matter what. If you haven't seen the other people's videos, I even did a video on the subliminals they used to do, trust the government, things like that, when they used to play the national anthem when the television stations would come off at night. But bury your pride and just look at what we're looking at. 251 degrees Celsius. Transfer that to Fahrenheit. This is just regular plastic wire going out to the camera. Don't worry, it gets better. Here's a close-up of the camera. Look at this plastic wire going up to into here. And then you have this on the front here. This isn't even coated. So now you can see all the plastic wire wrapping around this, going all the way up to the outside. Absolutely freaking nuts. Look at this thing. How much power do you think this thing consumed? Oh, brother. Technology, huh? Yeah. Yeah. Now, check this out. I only brought this in for a couple reasons. One, check out the foil here. Tin foil, aluminum foil, hell knows what. Would not withstand those temperatures. But here's the thing that cracks me up. Look down here at the pad. There's more dust in here than when it landed on the moon. The famous pictures where they're landing there, and there's no dust in here, and there's no blast underneath the the engine. Oh, guys, bury your naivety, please. We never went to the moon. Take care, guys. Oh, one last thing. They never were able to land us, ever. 100% failure rate landing this thing. And yet they said, oh, well, they'll be able to do it, and sent it up, and then everybody perfectly did it. Wake up.